Hello everyone, in this video we'll see a nonlinear data structure called binary trees. This is an introduction to binary trees video. So we will going to learn what is binary tree and what is a node and some of its terms, operations, applications, and how do we create that. Those are all in this video, we'll cover it up. Okay, now let's start with what's the term refers. Binary tree means binary and a tree. This structure is looks like a tree kind of structure. That's the reason it is named as a tree. And binary stands for the bi means two, and array is the terms for the representation. So two nodes are represented in this binary tree, and this is a typical example of a binary tree. And from the nature we got some of the example, and this is one of that. Actually this is a tree, and once you invert this image and you can notice this is a root, and there's several branches are spanning from the root, and it looks like literally a binary tree. Okay, what are all the terms that are involved in this binary tree is node are there, and root is there, leaf is there, subtree is there, and some of the relational items are there, which means the parent, children, and siblings. This kind of family relation are there in this binary tree. We'll see one by one. Okay, what's the node? Actually, node is a representation of data. So how this node will be is there is this is the binary node, and here I have some data. Since it's a binary node, I have two pointers to denote the children's. So that's namely as left pointer and right pointer. So if I have one more pointer called middle pointer, then that will be turned to as ternary trees. So instead of by, you will have ter, ter. This is how the computer representation will be. There will be a data, and there will be one pointer. The pointer is nothing but also a node, a pointer of a node, pointer for a node. So here I have left and right. In this tree also you can see this is going at the left side, so this is left pointer, and here one pointer goes right side, and here you can say this is a right pointer. It's displayed in maroon color for the left pointer, and right pointers are denoted in the green color. Okay, now what is a root? In this tree, this is where it starts. Actually here only it is starting from this one. So this is namely called as a root. So from this one only it's starting. This tree also you can look at it from the where it starts from, it will be the root. And next is a leaf. Leaf is the last level. So here I don't have any other children with this node 3 or 5 here in these levels. So I don't have anything here, right, left, nothing is there. So this is called a leaf. From the tree where it ends is called a leaf. So from here also it is don't have. How to compare this one to the actual tree, and you have to get some understanding with this. Okay, so in this tree 3 5, this 3 5 3 5, and this 3 5, these are all called leaf nodes. This all this ground level is named as leaf node. Okay, then subtree. What is a subtree is? So subtree, I have one tree. This is a full tree. From this tree I need a subset of a tree, literally named like this. This is called a subset of trees. So there is an actual tree, and this is a subtree. Each node itself will be a subtree. This is a subtree, and this is a subtree. this 3 3 5, this is one subtree, and if I move here on subtree, so wherever it is a subset of this big tree is a subtree. Okay, now parent, child, and a sibling. This is a kind of a relational items. So what is a parent and what is a child? This is this relation you can namely represent as a family tree structure. So if I have node 2, this is child, and here is my parent. So 2 is child of 1, and 1 is parent of 2. This kind of here you can assume this is a father node, and this is a children node. So this is father is namely called as parent. So and this is called as a children because it is a descendant, and this is an ascendant. So that's the reason you are naming this parent and child relationship. And sibling means it's a kind of a sister or brother. So when I have this 3, whatsoever in my level, this is called as sibling nodes. From this same here I have common parent, and here this 3 also is there, and this 5 also is there. So these are all in the same level and having same parent. So this is all called sibling nodes. This is the relation involved in this binary tree, but these are all for just a representational purpose. But in the actual interviews and other com- programmings, competitive programmings, you can expect like some tedious question, but these are all the basic terminologies just involved in this binary tree. Okay, what are all the operations that you can do with this so binary trees? Here I have a node. In order to construct like this, you must insert the nodes to this trees. So I'll pick a node like this, and I'll have this right left pointer, and I'll create this kind of structure and assign data in this pointer. So what the data will be is it will be like a character or string. It will be in any data type. In the real world examples, this data will be a very large strings, or it will be an object. It can be anything. So this node will be attached to this binary tree, means there should be a one incoming pointer this side, or else it will be a root node. Those are all the two ways that this binary tree can supposed to have. At the point of I have root node, I'll not any incoming pointers, but I'll have outgoing pointers as right or left. But when it already descendant node of any other node, so it will have one incoming pointers. Okay, now what are all the operation I can do is, first of all, I need to insert it. Okay, and if I don't want anything in this, I have to delete that. So how I can delete from this node, I can delete the node which having some children, or even I can delete some root node even. That's possible. And what's the replacement of this root node when it having, that's the separate case. We will have this separate second node, it will may come, the leaf node may come, may replace it. That's all up to the requirement. Okay, so removal also is okay. And the third is traversing. I can go and print the content of it. So that's called traversing. There is three methods are namely there, like pre-order, in-order, and post-order. Pre-order means you have considering the left as an important one, or you are treating the node as an important one, it is an in order. If you are considering the right as an important one, then it is a post order traversal. So we'll see those kind of three traversal in this. And next thing is searching. Searching is nothing but you are looking for an element in this tree. For example, I have some unique element called 500 in this tree, and you'll be given only the root node. You'll not have any intimation of what's the other data are. So you have this 500 data reference, 500 just value and you have reference to this root node. So from the root node you have to use some searching technique in order to travel like this and find this node. So those kind of operations that you can do this. And height of the node, height of this binary tree. Here you will have this terminologies like 2 power n minus 1. It may have n is the maximum number of levels, and this kind of how many nodes are there. These kind of things you can using some formulas and you can find it out. But in the real world and the programmings, what they ask is what is the longest path and what is the biggest depth, and those kind of things they'll ask. Here you can see 1 2 3, this is the maximum depth. So these kind of things you can expect from the operations. Okay, what's the use of this binary trees in a real world? And in networking, there is a routing tables. You can use these binary trees in place of that. And there is a decision trees. You could have seen in this is in machine learning subjects. These binary trees will be helpful. And expression evaluation, there is an operators like plus, minus, and into and all. There it will be like two numbers will be in left and right. So you'll insert it in one stack and take it back, and you'll evaluate it. And next is data compressions. Data compression is here some nodes or subtrees repeating. So I don't need to write the same thing again and again. Instead of that, I can point it to from the various pointers, and I can treat it as the data is repeating, so that data is no need to be saved again and again. So in place of that, this data compressions will be helpful with this binary trees. And sorting, you could have seen this binary search trees. The searching may be easier with this, and you can use those things to sort the numbers. So these are all some of the applications involved in this binary trees. Okay, now we quickly jump to the Visual Studio Code, and we'll write how to write a node structure, and we feed some content in that and print that values. Okay, now I have this basic setup. I'm using C++ compiler, so I'll just run it. My compiler is working fine, and I'm going to create a class called node, and I'll have some public properties like namely int data, and node pointer like left, and node pointer for right, and I should keep one semicolon here. I create node n dot. You can use this class variables with the dot operator. So n dot data equal to 10, and I'll print this as n dot data, and click run. My 10 is printed. So this is how you have to create a node. This public modifier is expected to be here. If you don't have the public modifier, it will throw the error because it can't access it outside. So this public modifier is required. Um, there is alternate options for this classes also. You can use structures. You can use struct instead of struct node. I'm using called mode. In this place you can use int data, the same thing, the pointer mode star left and mode star right. Here you can write mode m dot data equals 20, and equals cout m dot data. At the end of this you can print endl. Here also indel. Now run. 10 and 20 will be printed. This is the formal way to create a node structure, what was represented here. Okay, hope you have good understanding on this binary trees by watching this video, and we'll do these kind of operations and some of the programming problems involved in this binary tree in the upcoming videos. And thank you for watching this video. We'll meet in the next video.